All right, let's get on to we have some unit tests that need some help. Editor controls. Interesting. Let's leave that over there. These can come over here. These are the tests we will do. And hello, Elemental. Okay, so this is going to be a stream about working on the project. We're currently writing unit tests in order to make sure that every part of this client is correct, because we will be streaming and replicating databases, which, we want to be correct. So we're spending a lot of time just hanging out, chilling, writing some unit tests. There was one other thing I wanted to check. What was it? So this here, great. Okay. So the piece of code that we are going to be testing is in, let's see, it's used by Stream Database Updates. Yes, it's here. So sync databases. Let's mark the pieces that we still need to test. We need to test these branches. So basically both of these. One for the database not being found after attempting to stream, and the other, if we get an out of range, it should fall back to just simply downloading. So we can essentially copy the other test that comes into this section, but instead of streaming the database, we will return an error. We'll want the database to exist with a different checksum. So this would be a good one to copy. Oops. To everything in here. I know I don't normally stream in the evenings. I just wanted to hang out and get some more testing done. Let's see, give me just a second. Let's read through this and figure out what we need to change. Start with the database name. We will call it Happy5. Happy5, great. This test will simulate the server and client both having the same database with the client slightly out of date. When the client tries to stream the changes, the server will return good. A not found error. The client should then download the entire database from the server. Brilliant. So our database that we will be streaming is called Happy5. We'll create a new test context. There's lots of test tools and test context. One of those is creating a database on the server. It randomly creates a database. We copy that to the client, and then we mutate the server version. That should at least get us into this section here and past the sync check. So we should get to this point. And on this request, we're streaming the information, stream database updates. At this point, we want to, instead of sending all of the pages, we want to send an error. Not found. Okay. Let's do that. Stream send error. It is not this. This is a tonic status not found. And it could be whatever message we want at this point. We drop the stream, letting the client know. In fact, we shouldn't need that, but regardless. After we get that, we should get an error here, and then the client should start to download the database. Now, how do we download the database? We're going to go pilfer some more test code because it's end of the day. I am worn out from all the yard work today. We want it to be correct, but kind of low effort at this point. So, similar. It's going to call download database, which is this. This should be the end. Oh, what did I hit there? This should be the end of our test. So we'll get an event for fetch database. We will stream that. Stream the database for that. The client will remove the database and download it anew. And then after that, it'll start a stream of any changes that might happen in the future. So, like if the writing server has some sort of database mutation, then this code down here at the bottom would send and receive that mutation. Copy. Send the not found. Let's test this. It failed. Why? Okay, there's our error. Code not found. Great. Tonic status error. Was it not supposed to capture this? Wrong button. Tonic code not found. We get the response. We try to match the response, okay, or error. And for tonic code not found. Interesting. I wonder why that failed. And this is why we write tests. Everything compiles correctly. But we have some logic error. Database response, great. Okay, what did we get back? Twice? Was this called twice? Why twice? Oh, because we looped, maybe? Hmm. Stream database updates. I'm surprised that the debug on the response does not include the status. Anything past error means that the server tried to recover and the test is no longer valid. So we can ignore everything down here. Everything above error is the important piece. But well, that and the error itself. So both are interesting. And just to give everybody some context, we are working on a piece of software that has a few pieces. Okay. It's designed to be run on multiple machines. One machine would be a writer that does the mutations to a database. N number of other machines would be readers. The data written by the writer would be detected via a SQLite plugin, and the changes replicated via Dataplane, the piece that we're working on right now, would send the mutations to a server. The server would then replicate those changes to the N number of readers and update the application, update the SQLite databases. As you can see, there's a proxy. The proxy speaks to the applications and Dataplane. Dataplane to know if the application has all of the data that it needs to respond to requests. So, very specifically, we are working on Dataplane and how it boots up. When it boots up, how does it get the data from the archive server? And at this point, we are trying to, where's our test? Simulate if both the server and the client have a database. The client is slightly out of date. And then the client will connect to the server, try to stream the changes, but the server responds with an error saying, I don't have this database any longer. This is a time of check, time of use bug, right? We checked with the server has it, suddenly it no longer has it, and we need to handle the error. It should download the database to handle the error. Oh, that's interesting though. If it doesn't have it, there's nothing to download. That's interesting. Okay. So if we receive code like not found, the database is gone. There's nothing to download. What was I thinking? So we return this not found error. And for whatever reason, right, is the test code even reaching this? I don't know. It might be reaching this here and not actually this here. We see that it's hitting this line. You know, let's add a little print line. There we go. Automatic flowchart generation would be nice. Yes. I feel like that's a problem that's continuously being worked on. everybody's trying, well, not everybody, but it's like reporting. Reports. Everybody always wants a report. Okay. Now, what calls this stream database updates is called here. This is in sync database. We check to see if we have it. If the server has it, we don't have it. We attempt to download it. We do not handle so if we get a not found error here, I guess the same thing could happen up here with a range, couldn't it? Because when we ask to download a database, we give it a hash. We expect that it can give us the database that was represented by this hash. Yes. I appreciate y'all hanging out. I know I don't normally stream at this hour. Normally it's about 12 hours off from here. All right. What do we do here? If we get database not found error, we need to handle that. We do not want to download the database. It does not exist any longer. Just remove it. Okay. That does mean that our test is slightly different. We hit this point and we do not want to sync. We actually just want to return. Nothing else should happen after this. Okay. I don't really like this here. Rather skip something, but like it says some boolean that says, "Oh, we should stream after this or skip streaming." But I think this kind of error handling is reasonable here. Let's see what happens. Running test 1. Fascinating. We received this message. Could not find the database on the server, which I believe is what we said in our test code. So we did not hit this here. Hey, Lutak. Let's see, you ask, is Mac environment better than Linux, Debian, Ubuntu? I'd say, is a hammer better than a screwdriver? I don't know. I'd say it really depends on the artist. Use the tools that work for you. And the tools that you have access to. So why are we not getting this? We see the stream results. We had a debug right here, but it's not being matched. Are we not returning this error? Okay, let's check that. Let's get rid of the console. Is that not this error? It looks like it. We also did not see this. We saw this. And what's going on with status? Hey, well, welcome. If you have any questions about the language, let me know. I am trying to primarily make progress on this project. So, if it's not that much of a side, I'll entertain it. We did not get the error. That's strange. We did not get the debug. Are we -- no capture? Just the one test. Data plane. Fascinating. We're hitting in here? You mainly use PHP, JavaScript, HTML, CSS because you work on at a company which uses custom content management system like WordPress, but full hand coded with OOP. I used to work with a system called Communique that was built by a company called Day, later acquired by Adobe. And I would go out to different companies and teach them how to use it. There's a lot of customization that the companies would end up doing. What do we have here? Still not found. Okay. So it's not going through this? Is it here? Did I put this at the wrong place? So this was, we asked for a database response for a stream database request from a checksum to another checksum. So give it a range. That seems like the right place to do that. Then we open a file and start to process responses. Is it this one? I would be so surprised. I would not expect it to be this one. It is. Wow. Okay. That is unexpected. I would have expected that the primary response is where the error would show up, not in the streaming. Okay. So we can bail there. This we should move below. Database response, great. What do we want to do with this? It needs to be off of this guy. Okay, let's extract this out. We will not do with context. Let messages response equal that. And let's see, to give you a little bit more context, this is part of a Tonic gRPC server setup. So we are asking the server to stream database updates. And in response to this request here, we get an error, not found, out of range. And I thought that we would see the error with relation to this part of the request, not this piece. I'm surprised. So we're actually getting the error on the stream and not on the initial response. It's subtle, but I find it interesting. Let's grab this, move that below. We get a response. Messages. We'll just pass that through, handle the error. Now this isn't going to work because we need to await each time. Maybe we extract this out to a function. We need to do this as part of the while loop. So this. Either that or we handle it as part of the loop itself. Let's see. Database updates. Let's put this back here. Don't save that. Paste that there. So in this case, what are we expecting? Just going to comment this out for a moment to look at the types. Oh, that's right. I have, there we go. What does database updates stream? And on the type hints. Okay, so database updates, messages, returns a result option of the type. We could transpose it so we get an option to a result. So we can still while let some. And then handle the result just inside the loop. Now we have a result, and we can move this inside. This is such a weird place for it. Let's get it working first, and then we'll see if we can, make it nice and pretty. Okay, we deconstruct this, which is, I'll leave it as is for now. Come through here. All right. Let's give it a test. All right. Not found. Oh, this is great. Data plane. So it did hit this point in the code. Code is not found. Couldn't. And there's our message. We got the AOEU message. Database not found. Great. No. Why is it that it hangs? What is it waiting for? I think it's waiting on the test code to finish. Where does this get printed out? Let's check this. Who calls this? Database, stream database updates is called by two places. This is the one that we were concerned about. Let's go there. So we ask for a response. We do not get it. And then we print out database not found and return after removing the file. Great. So we return from sync databases, which as you can see, we called just above, and it goes back to its loop waiting for the next database. Okay. That seems reasonable. Now, our test code, we send not found, we drop the stream, it's fine. We await an event and nothing happens. We need something to happen, or we just remove the rest of this. I would rather have something happen. Maybe we could kick off the download database flow again. That would work. So it feels like we want to ensure that it goes around the loop and doesn't get stuck somewhere else. ServerDB still exists. We didn't actually delete it. So how about we send an event that says we have a new database called Happy5. Is that not this one? Nope. Getting close. At the beginning of our test, we need to capture the database created stream. It's basically a stream we can just send signals on to say a database has been created. So let's capture that. Now let's two pieces. And this is for this here. Now we're not going to actually create an event right here. Let's just put them next to each other. So that will replace this. And we will keep this stream around for a bit and use it down below. We will not be validating that they are identical. But we will send an event. Okay. The client will ask about it. The name should be Happy5. It is added. And we should see a get, let's see, a database info request happen. Like so. Okay. And that'll give us kind of a positive event saying this happened and continued on correctly. And it passed. Great. This is good. Let's test all of our tests. 5 passed, 1 failed. Ooh, interesting. Which one failed? Okay. Oh, the one we have yet to implement failed. Okay, that's great. Let's add, say, it's fine. We'll keep that. Branch needs testing. It does not need testing anymore. We'll remove that line. Okay, this was the big change that made it work. Moving that down. I still think we should refactor this. Let's see. And we have. Let's go and update some of those. Remove some of these ePrint lines. That one stays. Debug is clean. Great. Let's see, where was the it was in sync databases. Sync database. We now have testing for that. This one still needs testing. Okay. But we have this improvement opportunity right here. Where we can handle the error in a cleaner way. Hmm. We could do this just above. So we could pull this out of the loop, put it up above, chain it to this. What is this? And can we iterate on this? We can map the result of this. I don't know why. I just don't like the way this is laid out. It's interesting. Why does it even happen this way? I feel like we should try to move this error message up above. So instead of asking for the message over and over again, it feels like it should be an error on this. Oh, yes, that's exactly right. It should be on that. Problem happens to be where our test code is sending it. Our test code is sending it as part of the stream. Okay. If we want the test code to send this at the right place, then we have to change our test code. We have a little test harness. We've got our fake archive server. And when somebody goes to download, they come in here, let's say to stream database updates or something like that. And we send this event out. It has the sender, it has the request, but we always send that response. We always say, hey, everything's fine. You're good. We could set up a one shot. And at the TX end of the one shot, do this event that we send back to the test harness. Wait for the response here. If it drops, then we just send the default. That would work. Let's do it. We will send the TX there. We will await the RX. We do not want to unwrap. We want to match that. Fingers, come on. Fill match arms. Thank you. So if we do get something back, it'll be in the OK. And we'll just respond with it. If we get error, we'll just do the default. Error means that the TX was dropped. Response will be what? The Schmill, hello. Which editor is this? Good question, Sinbleed. This is the Z editor. ZED. What am I working on? We are working on adding unit tests to something that I call data plane. Data plane is part of a larger application stack where we replicate SQLite databases using a VFS plugin. This thing needs one of these. This will be, goodness. How do I get rid of that little pop-up? We just give the response back. Now does it know what the type is? It does. Result response inbound. Result database status. Seems about right. I like it. It gets out of the way. It works. I'm typically a Helix user. I really like Helix. NeoVim before that. I've been a Vim user since forever. It is not from JetBrains. Z is, let's see, where is Z? Z is z.dev. It's its own thing. It's not Visual Studio Code. It's not JetBrains. It's just an editor. I think some of the people that work on Z were part of the team that built Atom. It is not VS Code. It is not VS Code. Oh, you live Helix too. NeoVim before that? Same. Oh, thank you. You know, I've been chatting. This is the first time that somebody has said, you're on mute. I really appreciate that. That's also why I added the little, you know, visualized voice piece down in the bottom right. Thank you. No, I had no idea that I was still on mute. I took a drink of water, left it on mute. The technical name is Swirly Thing. I like the Swirly Thing. I could just sit here and watch it. I could just talk to the Swirly Thing. It feels like a little friend. Okay, but by changing this, we have just broken all of the tests, or maybe half of them. What's going on here? Arguments to this enum variant are incorrect. Oh, do tell. Let's see, mismatched types, expected enum, result, tonic response, unbounded receiver stream, bound. Oh, yeah, we want that to be Tokyo one-shot sender. Did I not wrap that in a one-shot? Oh, I did not. To there? Beautiful. Just so simple. Now, that only broke 2 unit tests? Oh, that's not bad. Okay. All right, well, let's fix those 2, make sure the tests still work, and continue on. Now I'm paranoid. I keep looking over at the mute icon. Now, what do we get back? So instead of a stream, we get a sender for some stuff. And what test is this? This is test DB sync if there are changes. Okay, so both the server and the client have a DB called Happy4. The server has some changes to DB4 on line 728. You know that unit tests are something that you missed out on in college? Unit tests and integration tests, they are fundamental. Especially working on like your own project, you can move so much faster. I mean, it applies at work too. You can move so much faster if you have a good baseline of unit tests and integration tests, because it just gives you confidence that you haven't broken anything. Oh, you're in uni right now. You touched a little bit on unit tests, but I don't think any of the courses cover integration tests. Oh, interesting. Yeah, this is fundamental. Now, these unit tests are actually integration tests. There is an entire test harness that I've had to build up in order to test this code that uses the tonic gRPC rates. So I have a completely fake server written out here. Right, how many lines is this? 200 lines plus something called context. Right, another 200 lines. So 400 lines of support code to write a, 30 line test. And really, if you look at this, it ends up creating an actual, like, a server, and it talks not over TCP, but over this duplex mechanism. So I've had to abstract everything in my code to be able to take certain types. But it works. It works, and it's fast. It really is fast, which is nice. Compile time's not too bad. But it's a lot of code just to test with. Normally, you can get away with maybe 50 lines of support code, and not 400 lines of support code. But, yeah, Tonic with gRPC stuff. That's quite a bit. Okay. Where were we? Oh, we were going to change this test because the stream that we get back, the sender type is a one-shot. So we need to give a response back, or we just drop it. But we can't drop it because we need to send a stream. So we need to respond with an OK response with a unbounded receiver stream. Is gRPC GNU RPC? It is not. So we're using a crate called Tonic. Tonic is a Rust implementation of gRPC. G here stands for Google, right? It's something that came out of Google. High performance, open source, general RPC framework that puts mobile and HTTP2 first. So I thought that would work very well for streaming database updates across the network. High performance, sounded nice. So yes, I'm using Tokyo, Tower, Tonic, Prost. You're missing SC24? What is SC24? Response is equal to okay, something. Say okay unit, and then we just stream.send response unwrap. Fine. It's going to whine at us, seriously. So we need to send results. I'm going to just copy this out. So we need to build this up. Result. Tonic response new. And the message is an unbounded receiver stream. Yes, of course, stream. We have to build that. Stream equals, oh, we need a stream sender, stream receiver is equal to, now this was, what was it? Stream dot colon wrappers. Oh, okay. So we just need to wrap the unbounded receiver stream. So let's say stream sender, stream receiver is equal to Tokyo sync APSC channel, unbounded channel. Great. Then we pass in the stream receiver and let stream It's a little bit more setup in the test, isn't it? So we have a stream that we will be sending back. This is a stream receiver that goes inside there. Okay. And then we send the response. Great. The one shot is sent. And then later on the stream sender, we send the database pages. And we drop stream sender to signal that we're done. Okay. That's not bad. I'm going to snatch that. Go down below. It's probably something very, very, very similar. Ah, no. This is where we want to send the error. Perfect. What do we call it? Stream sender? Stream response sender. We want to send back. It's not found. And it's done. Okay. Now, because we've done this, now we can go back to the other code and check in the right place. So all of this moves back up onto this here. So it's going to go up here. In response to that code, we will no longer have that. Oh, wait. Okay. This is a result. Database updates result. That goes there. We'll deal with that in just a moment. Now we need something called database updates. There. We do not want transpose on this. We want, what was it before? Oh, before this even. Dot with context, and we had some sort of error snafu. DB sync send snafu? I think it's more of a stream. Fetch. Wow, this left-right bounce is really irritating. Let's just go up to the errors. Delete, no. Do we not have a stream up here? Maybe we wrapped it in just a tonic status error. It's probably what we did before. Tonic status snafu. Okay, bail on that. Okay, those work. Great. Now we fix up above. This is much better having this up here instead of as part of the stream of content. Oh, the supercomputing conference. Where's that being held? You said that you're missing it this week. And just FYI to those of you that have followed the stream, I normally stream in the morning for me. So it's usually about 12 hours off from now. So just a heads up. If you do toss a follow on that, just FYI, normally it's not an evening stream. This is rather rare. Let's give it a test. Did we adjust the test? Oh, Atlanta. Okay, and this is the one that we have not implemented. Perfect. Perfect. Okay. That was a worthwhile change. Very nice. We need to remove all of that code. Let's get rid of that. Goodbye, safety net. 'Twas nice. Okay. There we go. Just kicking that off to the server. All right. So that's good. Now there's only one test left. Close that for now. What do we want to save? No, let's just squish it. Now the next one. Let's kind of look at both sections here. Nope, 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 not this section. Stream database updates, no. Run database stream, no. Almost there. Here. Okay. So this is the logic that we're testing. We're trying to cover all of the different branches. Now, the branch that we just covered, we skip this section, come in through here. We're not skipping a sync. And we came into this section here. Perfect. Now we want to come into this section. This one is arguably more interesting than the previous one, as it results in us actually trying to download the database, which has been tested up above. We don't have to do too much testing on that. Okay. Going to take this one, update the test. Having the same database with the client slightly out of date. When the client tries to stream the changes, the servers return a, let's see, checksum not found. No, that's not it. It will return a out of range. Okay. Happy 6. Create the database, copy it to the client, change the server version of it, start the sync manager, which is the code that we're testing. Database created stream, which we will use later for testing. We expect to receive a get databases in our test archive server. Database info, great. And then we get this very interesting stream database updates. So we need to send back not a not found, but a status like out of range. Not find the checksum for the database on the server. Okay, great. Now we send that back. What is this? Notify the client that a new database has been created. We don't want to do that because in this case, get rid of all of that. It should actually download the database. So let's find some test download code. Let's see. Change the server. Okay, download the changes. No, we want a full download. Skip. Nope, we don't want the skip. Getting closer. Test database download. Great. So we will expect a fetch database to happen, and we will stream the database. And then we should get a stream database updates event. We want these lines here. Oh, we need to grab the event though. Like so. Okay. A great question you ask. Does the database come down in a binary format or something like a CSV? So we actually deal with a binary format for SQLite. This is very targeted at SQLite. It's an easy database to use in development. It's quick enough. You can use it in production. And the goal of this project is to make it so that you can span out horizontally the reads versus the writes on a cluster. Now, the way that a SQLite database sits on disk, and we'll do this in a bit of a simplified example here. Let's move over to, oh, you know what? Here we go. No, it's not going to be a good example. Okay, so a database on disk is split up into chunks. Okay, and SQLite calls these pages. The default page size for a SQLite database is 4 kilobytes. Okay. So whenever you add data to the database, it might fill up a page with information. It could be unused leaf nodes. It could be the actual content that you put in some blob or number, right? And it's not obvious where the data ends up because SQLite uses B trees under the hood. So it's a stable format that is guaranteed to not change for a couple more decades, I think. Let's see. So pages, yada, yada. I'm looking for the date. I forget where it is, but it's like until like 2050 or something. B tree pages, so yeah, B trees. But basically, we detect when one of these pages has changed, and we sync that to the other machines. And so this might be page 1. This is page 3. SQLite. These are one-based ordering. Right? Page 5. And so we watch the writes that SQLite makes into the write-ahead log and replicate and write those to the other databases. Here we go, 2050. So yeah, that's interesting. Time for water. It is convenient, and page sizes in SQLite are always a power of 2. So they can go up to, let's see, what was it? I think we were just looking at it. 64K. Maximum database size would be this. What's that? Minimum SQLite database is a single 512 byte page. Maximum size would be, let's see, kilobytes, megabytes, gigabytes. No, it's more than 4 gigs. Oh, that many pages at this. And because that's a U32. And at 64K of page size, it's 281 terabytes for a single file on disk. But you generally don't see 65K pages. So should be all right. That, and I'm planning on also adding diffing along the way so that we do a binary diff of the data between the 2 pages, because there should be quite a bit of content that's the same. So do a binary diff, just send the data that's changed, compress it, whatever, and just to reduce network traffic. But that's something for later, much later. Zed, where are you? Okay. Back to Zed. So now we've basically copy and pasted this unit test. Let's see what it does. And it passed. Wow. Okay. All of these pass. That is wonderful. I think I did identify one place where we do not handle an error. Oh, for sending deltas. I'm sorry. There's a little streaming problem. Context gets lost. What do you mean for sending deltas? What's the context again? I think I was talking about binary diffs and just sending patches or compressed patches of binary data instead of the full 4K. Because I think that you could probably, reduce the amount of data by, at least 25%. Probably much more. That test works. Let's commit it. That's great. We did not have to actually change the code for this one. Yeah. Splash them. Pagazar, let's say you ask, is there a way to listen for change request queries before being applied and then distribute to different nodes rather than monitoring logs, meaning pre-processing rather than post-processing? Yes, and I'm doing that. So let me go back to our architecture view. SQLite sits in process of an application. Okay. And the way that the system works is that you will load a plugin that is a VFS, virtual file system, in SQLite. And so we see the change before it actually hits the disk. Okay. So technically it's pre-processing rather than post-processing. So we can basically send the data to both places at nearly the same time in order to update all of the other readers as quickly as possible. But the way that we do listen is by watching the writes that SQLite does to the different files involved. The write-ahead log is the primary one. And for all like effective, like intent, the write-ahead log is as much of the database as the actual file is. Yeah. So we have that. That's great. We are almost to the point of, let's do a little bit of a code review real quick, just to see if there's some place where we're not handling that should be handled. I know of one, just here. Oh, where does this get called? Okay. This function here gets called when data plane is starting up. So particularly on a reader, we're told you don't have any databases, or maybe you do, but you are not in charge. You need to sync to data archive. And once you are up to date, you might become the writer, right? The leader of the system. Or you might simply continue to be a reader, a replicant of the system. Yeah, getting data out of sync is very unlikely to happen. We will write it to disk and send it like one line after the next in code. I think it's more important to actually get it on disk than to start to send it. So we'll write it to disk and replicate it hopefully as quickly as possible. In fact, we're probably going to be using, I have it already set up, uh, a FIFO in order to send data between processes, because SQLite sits in process of the application. And so it will actually write to a FIFO the data that's been changed. Data plane will read it, and that should be very, very quick. And then yes, it just goes over the wire. So as fast as our little gRPC, legs can carry us. It's very similar. I was actually quite taken with a system called LightFS, which Fly.io uses. I looked into their project. It's on GitHub. It's very interesting. It uses a fuse-based file system in order to detect the changes and then replicates them. I decided that I wasn't all that, I didn't like the fuse-based file system part of it. It's one way of doing it. It actually makes kind of your life very easy. You don't have to worry about a VFS plugin and the challenges that come along with a VFS plugin. But it slows you down. Fuse-based file systems aren't very fast. So I'm going the other route, taking on the challenges of the VFS plugin and trying to make it fast or faster. I want to be able to handle, orders of magnitude more writes, more SQLite databases, etc. Okay, so when data plane boots, it may or may not have databases locally, but it will have a list of them that it receives here, and then it's told sync these. So it starts to sync them. It starts to do this by asking for information to archive server about a database. Tell me about this. Gets DB info back. Then it checks, does this exist locally? Oh yes, Superfly with Light VFS. I have not been following along with this. Oh, they're doing it in Rust as well. Interesting. I actually plan to deploy my stuff on Fly.io. But yep. That's interesting. I plan on supporting that. That's actually the only method I plan on supporting. Fascinating. Probably similar, but different. I am using Rust, yes. It's interesting that the last change was 8 months ago. That's generally not a good sign. Where's branches? They moved this around recently. Branch. Oh, there you are, branches. Active? No active branches. Oh well. But this is their fuse-based version here. 2 months ago. So this is my 594th stream of, and all I ever do is Rust. This has been my fourth year streaming, third year, fourth year. I don't remember. Feels like four. Oh, interesting. Yeah, it is actually. I had my anniversary just a little bit ago. I think I started in September about 4 years ago. Okay. So the client asks the server, give me info about this. We get the info. Great. What do we do? Does this ever fail? I don't know. Some of these we might need to handle. Figure that out later. Does the database exist? If it doesn't, then we will download it. Hmm. You know what isn't in here? If we have a database that the server does not. Oh, that's interesting. Okay, that's missing here. Generally, I don't think it's a problem. We'd have to see. Do we have the DB local? I guess it could be a problem. Let's say you had a forum, right? A website forum, and you stored every thread in its own SQLite database, right? Well, in order to list all of the threads, maybe a crude implementation would be to list the files on the file system and pull some information out of them. And if one of the readers had an extra file, then it would show up as an extra forum. So, yeah, maybe it could be a problem and should be deleted. Okay. So if the database does not exist locally, we will download it. There is the possibility that the database is not found because it was deleted between this request. No, not this request. It was an actual request up before this. Here. Run database stream. So we say database stream request, and then we get databases request. Give us the list of all of the databases on the server. So I guess it could have been deleted between this request, response, and us trying to stream it. So we should probably handle that. Where was that? I'm lost. Database stream. It's above that. Oh, I should use this cool tool. Sync database. Okay. That's the fix me we just added. Fix me. What if the DB is not found? Yes, we should handle that. So ideally, we would catch that here and just undo the create here and move on. Okay. So we need a test for that. We need a test for cleaning up databases that do not exist on the server. Anything else? That'll remind us. What's the other one? Tokyo test. Thank you. Async function. Test. That's right. Test client has databases missing on the server. Sure. Okay. I think it's looking pretty good, at least for a first version. We could probably, that's old, probably go from here and start implementing archive server. Because now we do have this nice interface defined. We've changed it a bunch, and I think it'd be fun to move on to data archive. Data archive is empty-ish, only 250 lines. Oh, I'm running out of steam. It's late for me. So let's see. Who could we raid today? Twitch. Browse. Oh, I want software. Was it software and there it is, game development. Ooh, what do we have here? Built in public. Fascinating. BB Cure. Nice. All right. Let's see if we can give him a raid. Well, thank you all for hanging out. Appreciate the well, just chilling, chatting. It's been good. So, until next time, y'all. Bye bye.